Have you ever wondered why we only see one face of the moon? It's a question that has puzzled stargazers and scientists alike for centuries. The answer lies in a fascinating phenomenon known as tidal locking. This celestial dance between the Earth and the moon ensures that we only ever get to see a single, unchanging face of our closest space neighbor. Imagine for a moment a ballerina spinning on one foot. Now, imagine that her spin is so perfectly timed that she always faces the same direction no matter how many times she twirls. This is precisely what's happening with the moon. But how exactly does this occur? The answer is gravity. The gravitational pull between the Earth and the moon causes bulges to form on the moon. These bulges act like handles that Earth's gravity can grab onto, slowing the moon's rotation down. Over millions of years, the moon's spin has been gradually slowed to match its orbit around the Earth. This synchronicity between the moon's rotation period and its orbital period is why we see the same face of the moon night after night. It's not that the moon doesn't rotate, it does, but it does so at the same rate it orbits the Earth. So, from our perspective here on Earth, the moon's face appears to stay the same. In reality, the moon is not alone in this behavior. Tidal locking is quite common in the solar system. Many of the moons around Jupiter and Saturn, for example, are tidally locked to their parent planet. It's a fascinating testament to the invisible forces at play in our universe, shaping the way we experience the cosmos. So the next time you find yourself gazing up at the moon, remember, you're always seeing its one and only selfie face. The moon, like that ballerina, is always spinning, always dancing, but always presenting the same face to its audience, us, here on Earth. Contrary to popular belief, the dark side of the moon is not always in darkness. Now, doesn't that statement turn your world a little upside down? Let's delve into this fascinating topic and shed some light, quite literally, on the moon's mysterious dark side. Firstly, it's essential to understand that the term dark side is a bit of a misnomer. It's been etched into our minds by pop culture, from Pink Floyd's iconic album to numerous sci-fi movies. However, in terms of astronomy, it's more accurately described as the far side. This far side is merely the hemisphere of the moon that is permanently turned away from Earth, hidden from our view. Here's where it gets interesting. The far side of the moon is not shrouded in perpetual darkness as one might assume. It receives just as much sunlight as the side we see from our earthly vantage point. The moon, much like our planet, experiences day and night. However, a lunar day lasts about 29.5 of our Earth days. This means that the far side of the moon spends about half this time basking in sunlight and the other half in darkness. This phenomenon is due to a process called tidal locking. Over billions of years, the gravitational interaction between Earth and the moon has caused the moon to slow down its rotation to the point where its orbital period matches its rotational period. This means the same side of the moon always faces us, while the far side, hidden from our view, experiences its own lunar day and night. However, this doesn't mean the far side is devoid of intrigue. It's home to one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin, and has a thicker crust with less Maria or lunar seas than the side we see. So the dark side of the moon isn't so dark after all. It's a dynamic world, bathed in sunlight half the time, shrouded in lunar night the other, and filled with geological wonders that continue to captivate scientists and space enthusiasts alike. The moon does more than just light up our night sky. This celestial body, our closest neighbor in space, has a profound influence on Earth, shaping the planet's natural phenomena in ways you might not realize. Let's start with something we've all seen: the tides. Ever noticed how the sea level rises and falls twice a day? That's the moon's handiwork. The moon's gravitational pull tugs at Earth's oceans, creating a bulge of water on the side of Earth facing the moon. This bulge is what we see as a high tide, but it doesn't stop there. Since the Earth also spins on its own axis, this bulge moves around the planet, resulting in 2 high tides and 2 low tides each day. But the moon's influence extends beyond the oceans. It also affects Earth's rotation. You see, billions of years ago, Earth spun much faster than it does today. Days were only about 6 hours long. Can you imagine? 4 days crammed into one 24-hour period. But the moon, with its persistent gravitational pull, acted like a brake, slowing down Earth's rotation. Over billions of years, this braking effect stretched our day from a brisk 6 hours to the leisurely 24 hours we know and love, and this is still happening today. Every century, the moon's gravitational pull adds about 2 milliseconds to our day. It might not seem like much, but over millions of years those milliseconds add up. So the next time you're at the beach, watching the waves roll in and out with the tides, or you're simply enjoying a lazy afternoon that seems to stretch on forever, take a moment to look up at the sky. That glowing orb is doing more than just providing a beautiful backdrop. It's shaping our planet's natural rhythms and giving us the gift of time. Next time you enjoy a long day at the beach, remember to thank the moon. Did you know that the moon experiences moonquakes? That's right. Much like our own planet, the moon isn't immune to seismic activity. But unlike the Earth, these lunar tremors, known as moonquakes, can last for an astonishing duration of up to an hour. Just imagine, that's significantly longer than earthquakes we're familiar with here on Earth. Now you may be wondering what causes these moonquakes. Well, there are 4 different types of moonquakes, each with its own unique cause and characteristics. First, there are deep moonquakes. These are caused by the gravitational interaction between the Earth and the Moon. They occur about several hundred miles beneath the lunar surface and are by far the most common type of moonquake. Next, we have vibrational moonquakes. These are caused by the thermal expansion of the lunar surface when it moves from the extremely cold lunar night into the scorching lunar day. The third type is known as surface moonquakes. These are very minor and aren't very well understood yet. They tend to occur on the lunar surface and are generally much weaker than the other types. Lastly, we have shallow moonquakes. These are the most interesting and also the most mysterious. They occur just a few dozen miles beneath the moon's surface and can register up to 5 on the Richter scale. That's equivalent to a moderate earthquake here on Earth. These shallow moonquakes are still a mystery to scientists as their cause remains unknown. Scientists study these moonquakes to learn more about our lunar companion's interior. By analyzing the waves produced by these quakes, they can gather information about the moon's internal structure, much like how doctors use ultrasounds to see inside the human body. So there you have it. The moon isn't just a passive, silent object in our night sky. It's a dynamic, geologically active world experiencing its own version of seismic activity. Moonquakes, another fascinating aspect of our celestial neighbor. We've learned a lot about our moon today. Our journey began with understanding the phenomenon of tidal locking, which has kept one face of the moon visible to us, while the other remains elusive. Tidal locking is a gravitational interaction where the moon rotates about its axis in the same time it takes to orbit the Earth. This results in one side, the near side, always facing Earth, and the far side, often misleadingly referred to as the dark side, hidden from our view. But the far side isn't dark at all. In fact, it receives as much sunlight as the near side. It's called dark not due to lack of light, but because it's unseen and unknown. It's a testament to the mysteries that the moon still holds for us to uncover. Speaking of mysteries, we dove into the moon's influence on Earth. From gravitational pull affecting our tides to its potential impact on life's evolution, the moon's influence is undeniable. It's a silent puppeteer pulling strings that shape our planet in subtle yet profound ways. And who could forget about moonquakes? Much like earthquakes here on Earth, the moon experiences its own seismic activities. These moonquakes suggest that the moon, often considered a quiet, static world, is far from dormant. It's a dynamic sphere with a life of its own. As we look to the future, lunar missions continue to take center stage. Scientists and space explorers are eager to delve deeper into the moon's mysteries. They hope to uncover more about its seismic activities, its internal structure, and perhaps even find evidence of water ice in its permanently shadowed craters. Every mission, every step we take on the lunar surface brings us closer to understanding our celestial neighbor. It's an exciting time in lunar exploration filled with potential discoveries and breakthroughs. As we continue to explore the moon, who knows what other secrets it may reveal. Until then, keep looking up.